Hello everybody! In this latest edition of our YouTube update, we are going to cover a very important standard applicable to laboratories, ISO 17025. It is a standard for laboratory accreditation covering test laboratories and calibration laboratories across the world. We have seen that in recent years, all the laboratories, be it a test laboratory or calibration laboratory, all are gearing up for ISO 17025 implementation and accreditation. So we thought this is the right time for us to come out with an update on ISO 17025 accreditation. Technically, this ISO 17025 accreditation is very much in sync with ISO 9001 standard. So, if you are a test laboratory or a calibration laboratory that has got some kind of exposure to ISO 9001 standard, implementing ISO 17025 standard should be relatively easier for your laboratory. So, let's briefly try to understand. 1. What is ISO 17025 standard? 2. What are the benefits for test laboratory or calibration laboratory from ISO 17025 accreditation? 3. What are the requirements of ISO 17025 standard? 4. What is implementation methodology? 5. And more importantly, how we, as the largest ISO 17025 accreditation consulting company, can assist you, partner you, and become your implementation associate in your ISO 17025 at Laboratory Accreditation Project. What is ISO IEC 17025 standard? Laboratories use ISO 17025 to implement a quality system aimed at improving their ability to consistently produce valid results. ISO 17025 specifies the general requirements for the competence to carry out tests and/or calibrations, including sampling. It covers testing and calibration performed using standard methods, non-standard methods, and laboratory-developed methods. It is applicable to all organizations performing tests and/or calibrations. These include, for example, first, second, and third-party laboratories, and laboratories where testing and/or calibration forms part of inspection and product certification. ISO 17025 is applicable to all laboratories, regardless of the number of personnel or the extent of the scope of testing and/or calibration activities. When a laboratory does not undertake one or more of the activities covered by ISO 17025, such as sampling and the design development of new methods, the requirements of those clauses do not apply. ISO 17025 is for use by laboratories in developing their management system for quality, administrative, and technical operations. Laboratory customers, regulatory authorities, and accreditation bodies may also use it in confirming or recognizing the competence of laboratories. What are the benefits for test laboratory or calibration laboratory from ISO 17025 accreditation? 1. National and international recognition. 2. Recognizes the technical competence of laboratory staff. 3. Assures the client that results are technically valid. 4. Provides comparability in measurements. 5. Decision makers can rely on the test result. 6. Improves staff motivation. 7. Ensures better support in the event of a legal challenge. 8. Assists in the development of new programs. 9. Reduces technical barriers in trade. 10. Saves money by getting it right the first time. What are the requirements of ISO 17025 standard? There are two main clauses in ISO IEC 17025: management requirements and technical requirements. Management requirements are related to the operation and effectiveness of the quality management system within the laboratory, and this clause has similar requirements to ISO 9001. Technical requirements address the competence of staff, testing methodology, equipment, and quality, and reporting of test and calibration results. Management requirements. Management requirements covers the specifications and compliances with respect to organisation, quality system, document control, review of requests, tenders and contracts, subcontracting of tests and calibrations, purchasing services and supplies, service to client, complaints, control of non-conforming testing and/or calibration work, corrective action, preventive action, control of records, internal audits, management reviews. Technical requirements. Technical requirements covers the specifications and compliances with respect to personnel, accommodation and environmental conditions, test and calibration methods and method validation, equipment, measurement traceability, sampling, handling of test and calibration items, assuring the quality of test and calibration results, reporting the results. ISO 17025 requirements in detail. Now, let us discuss clause-by-clause requirements of ISO 17025 standard. 4.0 Management Requirements. 4.1 Organisation. Laboratory must be legally identifiable. Identify and eliminate potential conflicts of interest within the overall organisation. Identify and eliminate departures from the quality system. Protect confidential and proprietary information. Avoid activities that would diminish confidence in the laboratory. Define the organisation of the laboratory and the interrelationships within the laboratory. Have technically competent management. Appoint a quality manager for the laboratory. Appoint deputies for key managerial personnel. 4.2 Quality System. Establish a quality system and document all policies, systems, procedures, and instructions. Create a quality manual to include a quality policy statement, management commitment to good professional practice, standards of service, objectives, personnel requirements, management commitment to comply with ISO 17025, structure of documentation, management roles and responsibilities. Ensure records are kept of all activities supporting your quality system. 4.3 Document control. Write procedures, SOPs, work instructions, guidelines that are important to plan, execute, and control test calibration activities. Control all procedures and identify and track all documents. Ensure document numbering, revision number, issue date, effective date on all the documents. Create and maintain a master list of documents. Ensure that only authorized documents are in use. Periodically review all documents and revise as necessary. Remove invalid or obsolete documents from use immediately. Uniquely identify each quality system document. Define and control the document revision process. Control documents of external origin. 4.4. Review of requests, tenders, and contracts. Clearly understand customer requirements and document all the inquiries. Keep records of review to check capability of the laboratory. Review subcontracted work. Notify customer of any deviations from the contract. Amend contracts as necessary, repeat the review process, and ensure that amendments are communicated to all affected personnel. 4.5. Subcontracting of tests and calibrations. Choose only competent subcontractors who comply with ISO 17025. Notify the customer that subcontractors are being used. Subcontractors must be approved by the customer whenever possible. 4.6. Purchasing services and supplies. Evaluate suppliers of goods and services that are critical to the quality of testing and calibration. Ensure supplier registration, supplier evaluation, and supplier re-evaluation. Inspect goods and services before use. 4.7. Service to the client. Understand the customer's needs and keep them informed of delays or deviations. Seek feedback from the customer and utilize customer surveys. 4.8. Complaints. Have a procedure for resolving complaints. Record all complaints and actions taken. 4.9. Control of non-conforming testing calibration work. Assign responsibility and authority for handling non-conforming work. Evaluate the significance of the non-conformity. Take corrective action. Notify the customer of non-conforming work. 4.10. Corrective action. Find the root cause of all non-conforming work produced by the laboratory. Select and implement the action most likely to eliminate the cause of the problem. Corrective action should be appropriate to the magnitude and risk of the problem. Monitor the progress of the corrective action to ensure effectiveness. Document and implement any changes indicated by the corrective action. Schedule an audit of the laboratory if the non-conformity brings laboratory integrity into question. 4.11. Preventive action. Identify needed improvements and potential non-conformities. Plan preventive action. Ensure effectiveness of the preventive action. 4.12. Control of records. Keep records of the quality system and of technical activity. Store the records suitably. Establish retention times. Keep complete records of calibration results made at the time of the tests. Mistakes in recording results will be crossed out and initialed, but not erased. 4.13. Internal audits. Audit the laboratory's activities at least annually. Auditors should be independent of the audited facility. Take timely corrective action if problems are found. Follow up on corrective action to ensure its effectiveness. 4.14. Management reviews. Laboratory executive management will periodically review the laboratory's quality system and activity. Maintain records like MRM agenda, MRM minutes, and MRM Action Plan. 5.0 Technical Requirements. 5.1 General. Many factors contribute to the correctness and reliability of tests and/or calibrations. The laboratory must account for these factors. 5.2 Personnel. Only competent, qualified personnel can execute procedures. Formulate goals for the education, training, and skills of personnel. Identify training needs and provide training. Keep records of authorization, competence, qualifications, training, and experience of personnel. Maintain job descriptions for all personnel involved in tests or calibrations. 5.3 Accommodation and environmental conditions. Provide proper power, lighting, and environment to facilitate work. Maintain the specified environment for testing. Prevent cross-contamination by incompatible activities. Control the access to testing areas. Ensure good housekeeping. 5.4 Test and calibration methods and method validation. 5.4.1 General. Use appropriate test and calibration methods. Estimate the uncertainty of measurement where appropriate. Keep instructions for the use of all equipment up to date and readily available. Deviation from established methods shall be documented and justified. 5.4.2 Selection of methods. Use validated test methods that are suitable for the task and which meet the needs of the customer. Methods published in international standards are preferred. Laboratory-developed methods may be used if they are validated. 5.4.3 Laboratory-developed methods. The introduction of laboratory-developed methods will be planned and effective communication will be ensured. 5.4.4 Non-standard methods. Non-standard methods will be approved by the customer and appropriately validated before use. 5.4.5 Validation of methods. Validation requires objective evidence that the selected method meets the requirements. All test and calibration methods must be validated. Record the results of validation and the procedure used for validation. The range and accuracy of values obtainable from validated methods shall be relevant to the customer's needs. 5.4.6 Estimation of uncertainty of measurement. Calibration and testing laboratories will estimate the uncertainty of all measurements. Where rigorous uncertainty analysis cannot be done, all relevant uncertainty components will be identified and a reasonable estimation of their magnitude will be made. Uncertainty estimates can be obtained in one of two ways. 1. Type A. Uncertainty estimates are obtained by the statistical analysis of data. For example, repeatability may be estimated as the standard deviation of a set of repeated measurements. 2. Type B. Uncertainty estimates are obtained by other means, such as finding the uncertainty of a calibration result on a calibration certificate, or the uncertainty in the value of a reference material from the material certification. In some cases, uncertainty estimates can be based on one's knowledge and experience, or on the laws of physics, or from knowledge about how a measuring instrument behaves. Procedure for determining uncertainty. 1. Determine what you are measuring. 2. Determine units of measure. For example, feet, pounds, percentage, etc. 3. Obtain uncertainty of calibration standard or equipment used for the test. 4. Evaluate repeatability. 5. Evaluate resolution, readability of all instrumentation. 6. Identify and evaluate other sources of uncertainty. 7. Prepare budget documentation. 8. Evaluate reasonability of budget. 9. Determine combined standard uncertainty. 10. Determine expanded uncertainty at 95% level of confidence. 5.4.7. Control of data. Calculations and data transfers shall be systematically checked. Validate and document all software written by laboratory personnel. Protect the data generated in the laboratory. Maintain the computers to ensure the integrity of test and calibration data. 5.5. Equipment. Provide equipment that is capable of achieving the required accuracy. Calibrate equipment before use. Only authorized personnel will operate equipment. Maintain a calibration record for each piece of equipment. Protect and maintain equipment. Remove defective or questionable equipment from use. Examine the effect of having used defective or questionable equipment. Update software to reflect changes in equipment parameters or correction factors. Calibration status will be displayed on all equipment. Prevent unauthorized adjustment of equipment. 5.6. Measurement traceability. Calibrate equipment before use. All equipment must have traceability to national, international standards. Reference standards shall be calibrated by a suitable agency. 5.7. Sampling. If sampling is employed, the sampling plan must be statistically justified. Follow procedures for sampling and record the results. 5.8. Handling of test and calibration items. Protect calibration testing items. Identify all items to prevent confusion with similar items. On receipt of an item, inspect it for damage, abnormality, and suitability for testing. Provide safe storage facilities. 5.9. Assuring quality of test and calibration results. Monitor and ensure the validity of tests or calibrations through certified reference materials, participation in interlaboratory comparisons or proficiency testing programs, and calculate Z-score. Z-score should be less than 2. Replicate tests or calibrations using the same or different methods. Retesting or recalibration of retained items. Correlation of results for different characteristics of an item. 5.10. Reporting results. ISO 17025 is quite specific about what must appear on reports from the laboratory, but also has a general requirement that the information must be reported accurately, clearly, unambiguously, and objectively. It must also be in accordance with any specific instructions in standard test or calibration method specifications. There is a relaxation of this if the laboratory is reporting within its own organisation or in the case of a specific written agreement with a client. In these circumstances, the report may be abbreviated, but nonetheless, all of the information required by the normal report format must still be available within the laboratory. Normally, the written agreement with clients to report in an abbreviated format should be concluded as part of a contract review. See section 7.3. Requirements for test and calibration reports differ slightly, but the following are common factors. 1. A title, test report, calibration certificate, test certificate, and calibration report are all mentioned as appropriate terms in the standard, but there is no compulsion to use these specific terms. 2. The name and address of the laboratory and the name and address of the client. If the test or calibration was carried out on site, the location of the actual work must also appear. 3. A serial number or similar unique identification for the report, which should appear on each page together with pagination in the form page of. An alternative way of indicating the total number of pages is also permitted, provided it allows the user to be certain about whether they have a complete document. 4. The client's identification details for the samples or calibration items and the identifiers used by the laboratory, for example, sample numbers. There should also be a brief description of the items and a note of their condition. 5. The date of receipt of the items and the date or dates of testing or calibration. Strictly speaking, the date of receipt is only required when it is critical to the validity of the results. For example, if testing needs to be done within a certain time of sampling, or where samples or calibration items require conditioning before being worked on. In practice, there are few occasions where the date of receipt has no relevance, so it's recommended that it be incorporated routinely. 6. Identification of the method used and any sampling plan or method which is relevant to the data. These may be a direct reference to a standard specification or may refer to a documented in-house method. In the latter case, a brief outline of the procedure, including any sampling methods, should be included. In practice, many accreditation bodies permit a generic statement indicating that the laboratory's standard procedures were used and offering the client a reference list on request. 7. A note of any deviations from a standard method and any environmental conditions which may bear upon the results. 8. The test or calibration results themselves with units. 9. The name, position, and signature or other identification of the person accepting responsibility for the report and the report's date of issue. It is recommended that the person accepting responsibility initials each page of the report where this is practical. It is up to the laboratory to decide who is identified as having authority to release data, for instance, sign reports. The onus will be to satisfy assessors that the person or persons so authorized have the appropriate skills to evaluate the data. 10. Where relevant, a statement that the results only apply to the items tested or calibrated. This is generally required in the case of product testing to prevent the results being applied inappropriately in support of general product or batch certification. 11. Preferably, a statement that the report shall not be reproduced except in full without the written permission of the laboratory. 12. The uncertainty of measurement. Note that this is compulsory in calibration reports. 12. Evidence of traceability. This normally requires details of the references used and cross-reference to their calibrations. 13. Unless there is a legal requirement, calibration reports should not carry any recommendations on a recalibration interval or date, since this might be taken to imply that the calibration has a specific time validity. Now, as an organisation expert in ISO 17025 consulting, we advise all the laboratories across the world to not fear ISO 17025. It is a different standard, but it is not difficult. With expert advice from us and our expert consultancy, we'll make the process very simple and easy to implement and value-adding. So come to us, talk to us. We'll tell you what to do to accredit your laboratory as per ISO 17025, be it ISO 17025 as per NABL, as per UKAS, DAAKS, DAC, SASO, IAS, LAB, or any other national accreditation board, we are confident of our process and consulting service quality to partner your laboratory to achieve ISO 17025 standard in the most effective manner. With our global clientele base spanning across 75 countries, you are sure to get the best professional advice one can get for laboratory accreditation when you work with us. You are welcome to our office or visit us at www.iso-consultants.com or send us an email at info@iso-consultants.com to get started. Thank you very much, and we wish you luck in your ISO 17025 implementation and accreditation project.